discuss the mensuration part regarding circles. Okay, actually circles are totally different from what we have in case of plane figures like square, rectangle, then rhombus, because here you are going to use a Greek letter pi whose value is 22/7. Okay, so consider this as a circle with a radius r. You know, radius is the fixed distance from the center of the circle to the circumference or the boundary. This is the circumference of the circle. If you want to find the area of circle, we have the expression pi r square, where pi is 22/7, whose decimal value is 3.14. Sometimes you might be using this when the radius is not a multiple of 7, like 10, 20, and sometimes the instruction says that you have to use pi 22/7. Now to get the area of circle, if radius in place of radius diameter is given, you can apply the formula pi d square by 4. Okay. Third, to get the circumference, which is same as perimeter, okay, we have the formula 2 pi r. We can also apply the formula pi into d, because 2 times the radius is diameter. Okay, sometimes we call of perimeter, sometimes we call of circumference. Okay, now suppose this is a wheel of a bullock cart or a horse cart. Now you have to find the distance covered by the wheel in one rotation. Okay, now distance covered in one rotation, this is 2 pi r. In n rotations, it will be n into 2 pi r. Okay, so if you want to find the total distance covered by this infinite, okay, then this total distance d equals to n, that is number of rotations, multiplied by 2 pi r. Okay, sometimes we can replace this as circumference. You know, circumference is 2 pi r. Okay, so the distance d can also be calculated if you know the circumference of this circle. Okay, now fifth expression, we are going to discuss about annulus. First of all, let us discuss what is annulus. Okay, it is the area between two concentric circles. But what are concentric circles? Circles having common center. Suppose we are taking two circles, okay, having the common center, then the area between the two circles shown by a shaded part, this is the annulus, right? So the area of annulus, this is equals to pi capital R square, that means area of outer circle, where capital R is this one, okay, minus area of inner circle, that is this one, whose radius is smaller. Okay, if you can take pi common, we have more simple expression, capital R square minus small r square inside bracket multiplied by pi. Still more simple, you can make it pi, you know, this is the difference of squares, capital R plus small r, capital R minus small r. Well, this is for annulus. Suppose the question asks, what is the inner circumference? To get the inner circumference, we have the formula 2 pi small r. To get the outer circumference, that means this, okay, outer circumference, this is equals to 2 pi capital R. Okay, and if you want to find the width of the annulus, this is the width of the annulus indicated by x. Okay, so to get the value of x, we have the difference of capital R and small r. So having known this relation, you can find capital R or small r if the thickness, that means the width of annulus is given. So this was about annulus. Now we are going to discuss about sector. A sector is the area between two radii. Plural of radius is radii. This is the center and this is the arc. Okay. So to get the area of the sector, now this is the sector. Area between the two radii and the arc. So it's a portion of a circle. Okay. And you are given the radius in between the two radii, the angle is given, okay, x degree, suppose. So in this case, the area of sector, this is equal to x by 360, that is angle at the center subtended, by 360 multiplied by pi r square. So it is a portion of the circle depending upon the angle. Now to get the arc of sector, that means you are finding the length of this arc. This is x by 360 of 2 pi r. Clear? Now if you want to get the perimeter of the sector, this is equals to, see, length of the two radii and the arc. This is called the perimeter of sector. So we have x by 360 of 2 pi r, which is the length of the arc, plus 2 times the radius. So this is all about a sector. Under this sector we are going to discuss about semicircle, quadrant. All these are different types of sectors. Okay. Now let's come to semicircle. A semicircle is also a sector in which the area between the two radii, that means this and this, is 180 degree. Okay. So this is the area what you have to calculate now. Okay. So for area of semicircle, we have, applying this formula, x is 180 degree divided by 360 degree into pi r square. Okay. So that comes to pi r square by 2. This is the area of semicircle. You can apply this directly. Okay. Now the length of arc, all these are under the semicircle. Okay. Length of arc means this is the length of the arc. So for this we have, again applying the formula x by 360 of 2 pi r using this sector. We have the formula 180 by 360 of 2 pi r, that comes to pi r. That means the length of this arc is simply pi r. This is only pi r. Okay. Now let us assemble these two under the heading perimeter. So perimeter of a semicircle, that means this whole length of arc plus this straight boundary. So it is 2r plus pi r. Okay. Now we are coming to discuss about the quadrant. Quadrant is 1/4 of a circle. Because a circle has 4 quadrants. Okay. So this is one quadrant. This is the length of arc. And these are the two radii which are closing this. So for area, now this is about quadrant. For area of quadrant, we have pi r square by 4, because putting in this value 90 by 360 of pi r square, it comes to pi r square by 4. For arc length, applying this formula, 90 by 360 of 2 pi r, it comes to pi r by 2. Okay, because this is half of this. Now to get the perimeter P, this is equal to 2r plus pi r by 2. Okay, so this finishes circles. So I think you might be getting lot of information regarding the different portions in which the questions could be asked. Okay, so if you solve the questions, I think this will be very helpful for you. Okay, so please enjoy doing the questions from your reference textbooks. Okay, thank you.